In this video, we're going to find the slope of the tangent line to the function x cubed minus y cubed equals 6xy at the point negative 3, 3. So this is going to involve implicit differentiation. I'm going to show you a notation that I like that I think is a little shorthand for solving these. So I'm going to be using implicit differentiation, which means I'm thinking of y as an implicit function of x. So I'm going to be taking the derivative of both sides with respect to x. And so when I take a derivative of an x term, it's just its regular derivative. So the derivative of x cubed is 3x squared. Nothing crazy going on there. Now here's where implicit differentiation comes in. I'm thinking of y as a function of x. So I take the derivative of the y term, which is 3y squared, but because y is a function of x, it requires a chain rule. So I need to multiply by the derivative of y, which I'm going to denote y prime. So one way of thinking about it is anytime you take the derivative of a y term, you multiply by a y prime. Now over here, this is one where you got to be careful because this is actually going to be a product rule. We get 6x times y. The x times y is going to require a product rule. So let's put the 6 out front and talk about the product rule here. So the product rule is going to occur on this xy term. So first we're going to have x times the derivative of y, which is y prime, because it's an implicit function of x, plus y, and now we're just going, the derivative of x is 1. Now, there's a couple different approaches we can take next. First, we can solve for y prime explicitly, or we could plug in negative 3, 3, and then solve for y prime to get the slope at negative 3, 3. But if possible, we should always try and solve for y prime. So we got 3x squared minus 3y squared y prime equals 6xy prime plus 6y. At this point, the steps are always the same. You get all the terms with y prime on one side, all the terms without on the other. So let's put all the y primes over here. So I'm going to move this term to this side by adding it to both sides. Add 3y squared y prime plus 3y squared y prime. This term I'm going to move by subtracting from both sides. So that gets rid of that over there, gets rid of that over there. I end up with 3x squared minus 6y equals 6xy prime plus 3y squared y prime. Here's why this works so well. Both terms on the right-hand side have a y prime in them. I can factor that out. Y prime times 6x plus 3y squared equals 3x squared minus 6y. And finally, to solve explicitly for y prime, I divide 3x squared minus 6y over 6x plus 3y squared. Now, what we're going to do is evaluate y prime to get the derivative at 3, 3. We're going to evaluate y prime at the point negative 3, 3. So we're going to plug in negative 3 for x, positive 3 for y, and we're going to do that again on bottom. 3 times that 3 squared. And all done, we're going to have negative 1. So that's the slope of the tangent line. The point that it goes through is 3, negative 3. So the equation of the tangent line is y equals negative 1 times x minus 3. I got my negatives backwards. Sorry, this was negative 3, this was positive 3. So x plus 3 plus 3. This one actually simplifies quite a bit. If we wanted to distribute that, we have negative x minus 3 plus 3, and it turns out that it's just going to be negative x for the slope of, for the equation for our tangent line.